My favorite student. Chelsea, can you read that to me? Ann Surkey, she gets everything right. It's amazing. Number 1 says, draw a Venn diagram to show, okay, the universal set U, where I'm pulling everything, are the natural numbers from 1 to 30. So somewhere in here, 1 to 30 should appear. And then there are going to be some subgroups. There's going to be E, F, and S. So there's going to be E. I'll tell you how we'll mark this afterwards, but I'll show you how I draw it first. F and S. Okay. Set E is multiples of 3. That means 3 goes into these numbers evenly. That'll be like 3, 6, 9, 12. Set F is multiples of 15. That's going to be 15 and 30. And set S is multiples of 9. That's going to be 9, 18. But I'm going to go systematically one number at a time so that I can figure out which ones belong in 2. I'm going to start with 1. Where am I going to put a 1? On the, yep, 1, comma. Where am I going to put a 2? Outside. Where am I going to put a 3? Now I got to think. In E and F, in E, let's see here. So 3 belongs to this. Does 15 go into 3? No, 3 goes into 15, but that's not what multiple means. Does 15 go into 3? No. Does 9 go into 3? You know what? 3 is going to go right there. What's next? Then? And I've spotted a pattern already. I think I'm going to have to be paranoid every third number, but the rest of them are just going to be outside. So 5 is going to be outside. Okay, 6. 6 is a multiple of 3. It belongs here. Is 6 a multiple of 15? No. Is 6 a multiple of 9? No. You know what? 6 is going to go right there too. 7, 8, 9. Oh, 9. Ding, 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 ding. 9 is a multiple of 3. It's going to go there. Is 9 a multiple of 15? No. Is 9 a multiple of 9? Yes. Okay, so 9 is going to go right there. 10, 11, 12. Okay, 12 is a multiple of, you know what? 12 is going to go right here because 9 and 15 don't go into it, but 3 does. 13, 14, 15. Now 15 would go in the 3 circle, in circle E. 15 will also go in circle F. Will it go in circle S? So 15 has to go right there. Has to. 16, 17, 18. I think 18 is going to go right there. Amrit, then we have 19, 20, 21, I think is just going to go in this section because 15 and 9 don't go into it. 22, 23, oh heck, 24. 24 is going to go in this section right here. 25, 26, 27, I have to be careful. Good day, sir, my lateling. 27, I think, is going to go right here. 28, 29, where's 30 going to go? Here? Where's 30 going to go? E and F. Did you say and? And now we're talking about what the word and means in terms of logic. It means an overlapping Venn diagram. Okay, now I got them all. How would I give out marks? I would probably say 1 mark off for each number you have in the wrong place. So if you have 4 numbers in the wrong place, you get 0. You should have then 1, 2, 3, 4, 5 in circle E by themselves, E only. 2 in the overlap of E and F, and 3 in the overlap of E and S. You should have nothing in the middle. There's nothing that belongs to all 3. You should have nothing between S and F. There are no numbers less than 30 that 9 and 15 go into. If I had extended this up to 45, 45 would have been the first number that both 9 and 15 go into evenly. So 1 mark off for each number that's wrong. List the disjoint subsets. Which groups have no overlap? Does E overlap with F at all? Yeah, right there. Does E overlap with S at all? Right there. Does S overlap with F at all? Nope. And remember, the word disjoint, and I break it down. Dis, I know means not, and I see the word joined in there. Disjoined means no overlap in my mind. That's the fancy word for disjoint. So the disjoint subsets, F and S, have no overlap. One mark. Then we have, is each statement true or false? You need to remember what this long C on its side means. What the heck does that symbol mean? Is a subset of. So, E subset F, here's what it's saying. If you're a multiple of 3, does that automatically mean that you're a multiple of 15? Say what? If 3 goes into you, does 15 automatically go into you? So is E a subset of F? No, F is a subset of C. If 15 goes into a number, does that mean that 3 goes into that number? Always. But if 3 goes into a number, does that mean that 15 goes into a number? No. And you can also see from the picture, it's saying, is all of E inside F? No, there's some numbers outside of F. False, 1 mark. You can just put F and T. Is S a subset of E? Okay. Is S a subset of E? If 9 goes into a number, does that automatically mean that 3 goes into that number? Well, do I have anything here in S that's not inside E? In the diagram, everything that's part of S is part of E. And in English, yeah, if 9 goes into a number, then automatically 3 goes into that number. Absolutely and positively it does. I have to squeeze. There we go. Power off. Sorry, we'll pause the video here. So this one here I think is true. If 9 goes into you evenly, 3 automatically goes into you evenly because 9 is 3 times 3. So some of these you could almost reason your way to without the diagram. Sometimes the diagram is easier. Sometimes the logic and reasoning is easier. S is a subset of F. True or false? If 9 goes into a number, that automatically means that 15 goes into it. Sorry, if 9 goes into a number, that means that 15 also goes into it. Is that right? If 15 goes into a number, that means that 9, I said it backwards, and I caught myself, and I was staring and thinking, and I saw you looking at me, and I was reviewing my words, and I said, I got that backwards. If 15 goes into a number, that means that 9 goes into a number? No, that's false. And you can also see it here in my diagram. There's no overlap between F and S. Now, if we extended to more numbers, sure, but between 1 and 30, no. F prime, oh, what did the prime mean? What was the fancy word for that? It began with the letter C. It's what your mom likes to say to you fairly often. Compliment. Compliment, okay? The opposite. So I said, true or false, F prime is all the numbers from 1 to 30 except 15 and 30. What's F? 15 and 30. What's F prime? Everything else? True. 5. What did you say here? In English, here's what this is saying. If 9 goes into a number, then that means that 9 goes into a number. Is that true? In fact, any set is automatically a subset of itself. We call that, Alyssa, the trivial case. If 5 goes into a number, then 5 goes into a number. If 9 goes into a number, then 9 goes into a number. You know what? True. Set A is always a subset of set A because set A contains everything in set A, which sounds really obvious in hindsight, but turn the page. I think that first page is out of 10.
Yep.
So you can give yourself a little score if you want to out of, count them, 10 on the first page. If you had your quiz here or had done the quiz. Jordan asked 40 students at his school cafeteria what they bought for lunch. 34 students bought a beverage, 18 bought soup. Okay, I'm going to have some kind of a Venn diagram here. So I'm going to start out with yoink. And if I really want it to be clever, I might even be able to go yoink. And, hey, I just thought of this now. Yoink. There we go. Beverage, soup. Okay. This is key, and maybe I didn't emphasize it enough, so Logan, I want to emphasize this now. People, I want to emphasize this. This is important, people. I want to get your attention and make sure you pick up on this. If I am creating a Venn diagram from a paragraph of data, where do I always start? In the middle. Either they told me the overlap or I'm going to put an X there. So now I read the question carefully and I ask, did they tell me how many kids bought a beverage and soup? Everybody say no.
No.
So you know what? I'm going to say, that's how many. That's how many. And I'm going to say, need a little bit more room. There we go. How many kids bought a beverage grand total? 34. But I'm not going to put a 34 right here. How many kids only bought a beverage? Algebraically, if X bought both, how many only bought a beverage? 34 minus X. How many bought soup? 18. How many only bought soup? 18, take away X. How many bought neither? Now, right now, I can't solve this. I need more information, and there is one piece of information I haven't used yet. Which piece of information? All of these kids have to add to 40. That group plus the overlap plus the right-hand circle plus what's outside. Hey, this is actually a Math 8 equation. In fact, Grayson, you'll notice a couple of your x's cancel, which is convenient. I get 38 plus 34 plus 18 plus 5. 34 plus 18 is 52 plus 5. 57, I think? I get this. 57, and then this minus x just drops down like a domino. Now, often you'll be able to solve this part, Sterling, in your head. 57 take away what is 40? I think 17. But if you can't, you can always still go minus 57 from both sides. You'll get a negative x dropping down equals negative 17. What happens to the negatives? They cancel, and you get x equals 17. Hannah, what's x? X is the same as what? Nice and loud for a reason. What can I replace every x with? 17. So wherever I see an x, what can I write instead? 17. Okay, this is important. What that means is this, kiddo. 17. Right? Oh. 1. 18 take away 17. 34 take away 17. Also 17, I think. Now, and only now, Logan, can I start to answer the question. I had to put together the Venn diagram first. I like this question. I like this question. I like this question.
Is this question going to be on the test?
Almost certain. Definitely. There's going to be a question, Kyle, where I give you a Venn diagram. I don't give you the overlap. You'll have to put an X there and subtract your way out and get an equation. Now, how many students bought a beverage and soup? 17. 1 mark. Oh, for the Venn diagram for 1 mark, if you have any numbers wrong, I'll say each number that's wrong, you lose a half mark. So if you have 2 numbers wrong, you're out of luck. How many students bought only a beverage or only soup, but not both? Darian, 18. Number 3. Total of 20 students are on a field trip. Of these students, 3 are wearing sunglasses and 4 are wearing a hat. Only 5 students are not wearing a sunglasses or a hat. Okay, you know what? I'm going to be clever and go click, click. You let me pick all 3? No? Okay, never mind. I'm going to freehand this one. It's going to be ugly. No, I was trying. Is OneNote. I guess it has a different syntax. So I have sunglasses, hat. Did they tell me how many are wearing both? No. Otherwise, because if they do, it's a lot easier because instead of having an X, I've got a number there and I can already just start subtracting my way out. For now, X. How many wore sunglasses? 13. Take away X for a total of 13. How many wore a hat? 6 minus X only wore a hat. Oh, 5 wore neither. Now I get my equation. 13 take away X plus 6 take away X plus 5. That has to equal, please tell me, 20 kids. Woohoo! 13 plus X is 19 plus 5 is, I think you get 24. Take away X is 20. Alyssa, I think I can solve that in my head. 24 take away what is 20? What's X? X is the same as? Wherever I see an X, what can I write instead? I'm sorry, but this is fundamental. I'm going to emphasize it. I can replace every X with a 4, which really means 4, 9, 2. Now I can answer the question. So Venn diagram, half mark off for each number that's wrong. How many students are wearing both? 4. How many students are wearing sunglasses but not a hat? Oh. 9, or is that a German saying no? 9. How many students are wearing a hat but not sunglasses? 2. Turn the page. Looks like this time we got cats and dogs. Did they give me the overlap? Nope. Okay. X. 8 take away X. Also 8 take away X. 4. What's my equation going to be? 8 take away X plus 8 take away X plus 4 has to add to 20 kids. Yay. I get 8 plus 8 is 16, plus 4 is 20. So I get this. 20 take away X equals 20. Ah. Hey, Laura, what's X this time? It's a trick question. 20 take away what equals 20?
Oh, 0.
Yeah! So, Laura, ready? What's the overlap this time?
0.
Nothing. In fact, technically, if I was drawing this, it should be a Venn diagram that looks like that with no overlap. I won't take marks off. I would only take marks off if you filled in the overlap, because Carson, I usually assume there's an overlap and then find out after that there was not. But yeah, okay, so nothing, which means still 8, and 4. I guess none of these kids have a cat and a dog. 0. I don't know why I didn't ask more questions with this one, but oh well. Can you give yourself a score at the top of your quiz, please, out of, count 'em, 19? Last day we looked at Venn diagrams part 2, which was essentially, basically, 3-person Venn diagrams. 3 grouping Venn diagrams. 3 grouping Venn diagrams. And so I'll start out with my usual, hey, any questions from the homework? Now is your chance to ask. Yep.
The group work question at the end.
Which was number what?
It didn't have a number. That one.
Oh. I don't think I assigned that. Oh, well. We'll try.
I just want to try just...
Okay. Blah, 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 blah. Please tell me they gave me all 3. No. Okay. Complete each section. So how many watched both CSI and Survivor? 25. So this one here, let's do this first of all, Mr. Dueck, and then let's up this to about 250. I'm probably going to start it and then not finish it because it's going to take a while, Ben, but we'll see here. I think I would go 25 minus X. Okay. How many watch, you know what, I'm going to start at the bottom, work my way up. How many watch Survivor and Amazing Race? 30 minus X would go there, and that gives me a total of 30 that watched Survivor and The Amazing Race. Then we have CSI and The Amazing Race. That would be 27, so we would go 27 take away X. 40 watched The Amazing Race. Okay. I think here is going to go... let's think, Mr. Dueck. How am I going to fill this in? It's going to be 40 minus all that. So this is going to be 40 take away 27 minus X, take away 30 minus X, take away X. And you'll notice, Ben, that simplifies because I have a minus minus right here. And I have a minus minus right here. Really what this works out to is 40 take away 27, take away 30, plus 2x's minus 1x. Okay? You're going to do the same thing for here. You're going to do the same thing, same trick for there. Remembering that you have brackets. And then, if you add up this region, 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 careful with your brackets, that has to add to 102. And you can solve for x. So it's doable, but I'm going to pause. I'll do it later if you want to.
Okay.
Were there any before that? I'm not going to give you one this tricky on your test, although it's nerdily cool. Any from before? Going once? Can I do number 8? Sure. Sorry? But same one too? Okay. So, I kind of did this a little bit with somebody the other day, but I'll start it again. 3 categories, 3 circles. 3 categories, 3 circles. Yes, Taylor? Easy for me to say. So I said, okay, I got... did you draw the circles already? Did you try this? Okay. Did you draw the circles already at all or not? No, okay. So I just want to see if I make my Venn diagram looks like yours. So I'm going to go 2 circles on the top, 1 circle on the bottom, kind of a Mickey Mouse thing. And we're going to have biology, chemistry, and physics. Okay. How many teachers grand total? 21. I'll come back to that. That's probably going to be important. No one teaches both biology and physics. You know what? This whole section is going to be empty because anybody in those groups teaches biology and physics, and this question said no one does. Eight teach biology, of whom 5 don't also teach chemistry. Okay. Mackenzie, look up. Okay. How many teachers teach biology? 8. How many don't teach chem? Okay. Sorry, I'm not going to start until I have your full attention here. So sharpen the pencil or wait and get this later. But, okay. Okay, we're ready? I got you back. How many teachers teach biology? First of all, you understand why I colored in that black area? Okay. How many teachers teach biology? How many don't teach chem as well? 5. You know what? It's got to be 5 and 3. There's 8 teachers that teach chemistry, 8 teachers that teach biology, 5 of whom don't teach chem. That's the only way I can make that work. How many teach both chem and physics? Right? How many teach physics? How many do I have right now in the physics circle? So I guess I got to put 4 here. Now, I've used this up. I've used this. I've used this. I've used this. You'll notice I don't know what goes here yet. Wait a minute. What number did I say we wanted to remember at the very beginning that we kind of have forgotten about? How many teachers do I have here so far right now? How many teachers do I need? Where's the only place I can stick those extra teachers? It's got to be like that. So now I can answer the question. How many teachers teach chem or physics? That's going to be this, 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 or this. All of those teach chem or physics, or both. So 3 plus 3 plus 3, 9 plus 4, 13. Is that what it says in the back of the book? I hope. It says 16?
Yeah, it's 16.
Where's my 6? I did this last time. I did this with the... Where's supposed to be a 6? In the chemistry, someone said 3. It's a 6 because there's 15 teachers and 21, right? 6. There we go. And that gives us our... I did the same mistake when I went over this with somebody either in class or after school. Dumb. At least I'm consistently dumb. 3 and 3 is 6, 12, 16. Okay? Number of teachers that teach only one subject, 5 plus 6 plus 4. Okay? This is a tricky question. I would consider this, Mackenzie, B plus A minus level. Okay? But absolutely the stuff that I gave you on the quiz today, to me, is fundamental. You can expect to see a bunch of that. I would take more questions, but I want to get at least part of the lesson done today. So can we turn to lesson 5? Lesson 5, and while you're turning there, I need to do attendance before I forget because I'm missing a bunch of kids. It says this, there's a little blurb here. Hey, if you're in Alberta, you don't need to learn this, but we're in BC. Okay? We're going to start to try to actually categorize statements. And the first one we're going to start to talk about with is a conditional statement. So are you ready? First of all, in Canada, to be eligible to vote, this is knowledge that you need beforehand so that you can tell whether statements are true or false. You need to be a Canadian citizen, you need to be at least 18, and you need to be on the list of electors, you need to be registered. So assume that for this lesson, when I say a Canadian citizen 18 years of age or older is used, the person is registered, because there's always someone nitpicky who says, hey, there's another condition that we haven't talked about. So if I start talking about an 8-year-old Canadian citizen, we're going to say they're registered to vote. Got to be fussy. You ready? A conditional statement is a statement that is written using if and then. Any of you that have done programming, you have used if-then statements like crazy. A conditional statement has two parts to it. A hypothesis, the if this is true. Then a conclusion, the then part. A conditional statement, which is often called an if-then proposition, may be true or false. So here's let's see. If a Canadian citizen is 18 years of age or older, then a person is able to vote. True or false? Read that statement. If, then. Yes? Let's put a big T there. If a person lives in Victoria, then the person must have been born in BC. True or false? False. Is it possible to have lived in Victoria and not have been born in BC? Yes. Now, proving something true, very, very difficult. Proving something false, all you need is one counterexample, and you have proved the if-then statement false. If you shoot me with a bullet, they won't hurt me. Proving that statement true, very, very difficult. What would be the easiest way to prove that statement false? Shoot me. Okay? All you need is one counterexample. And we almost always use that because it's so out there, but it's so obvious as well. That's an obvious counterexample. But turns out there are some conjectures that we have not been able to prove true or false. Put your pencil down. Goldbach's conjecture, very famous. It's been around for about 150 years. Goldbach was a mathematician, and he noticed a pattern. He said, you know what? He said every even integer greater than 2 can be written as the sum of two prime numbers. Give me an even number between 2 and 100. 8. You can write that as 5 plus 3, prime plus prime. Give me another even number between 2 and 100. 80 can be written as 3 plus 77 doesn't work. 5 plus 75 doesn't work. 7 plus 73. Those are both prime numbers. Give me another even number between 2 and 100. Even number between 2 and 100. 96. That can be written as 3 plus 93 doesn't work. 7 plus 89. Those are both prime. This has been checked up to 4 times 10 to the 18th power. We don't know if it's true. We haven't been able to prove it. And all we need is one counterexample, and it might be false. We think it's true. If you asked me to bet $1 million, if you forced me to bet $1 million, I'd bet that it's true. Has not been proven. In 1938, Niles Pipping verified it up to numbers less than 10,000 by hand. This is before calculator days. Proving something true, very tough. All you would need to have Goldbach's conjecture come crashing to the ground is find one even number somewhere up in the heptillions that you could not write as the sum of two primes, and this would be a false conjecture. But we don't know, which is why it's still called Goldbach's conjecture. Not as theory, not as law, not as rule. It's we're pretty sure. Pick your pencils up. Back to the lesson. Oh, there are a bunch of very simple ones in number theory like that an elementary school kid can wrap their brain around. We have no proof for. Some we have proved. Converse. A conditional statement has a converse, which may or may not be true. This occurs when the hypothesis and the conclusion are flip-flopped. The then becomes the if, and the if becomes the then. So, in this example here, If a Canadian citizen is 18 years or older, then the person is able to vote. The converse would be if a person is able to vote, then the person is 18 years of age or older. Is that true? So here's an example of an if-then statement whose converse is also true as well as the statement. Our original statement was if a person lives in Victoria, then they must have been born in BC, which we said was false. If a person was born in BC, then the person must live in Victoria. True or false? False. But that is the converse. Converse, you, listen close, reverse the converse. That's how I remember it. You flip the if and the then. You interchange them. You reverse them. Write the following statement as a conditional statement, and then we'll identify the hypothesis and the conclusion. Here is the statement. An acute angled triangle has 3 angles that are each less than 90. Here is the conditional statement. If we have an acute angled triangle, then what? Can I use that for less than? I'm going to. 90 degrees. There's our statement. Now, first of all, what is an acute angle? It's one that I have a crush on. No, that's a cute boy, Rachel. What's an acute angle? You with me? You awake? I know. Acute angles are smaller than 90. They're cute, and it's a dumb way to remember it, but oh, a little small angle, oh, how acute. Okay. I should have been wearing my Hell's Angles shirt that has these on there. I didn't wear it today. Dumb of me. What do we call this one right here? Right angle. What do we call bigger than 90? Obtuse. Okay. Also what your mom may say to you, as well as compliments. They may accuse you of being obtuse. Okay. That's a whole different area. So, true or false? If we have an acute angled triangle, then all 3 angles are less than 90 degrees. Because why? Oh, well, triangles add to 180, 60, 60, and 60. Can you think of a counterexample? What if I had 89 degrees, Mr. Dueck? Well, then the other 2 would be 44 and 45. Or, you know, I'm trying to think of all the possible biggest acute angle, smallest acute angle, and every combination I come up with satisfies this rule. And that's the quick way to try and prove a hypothesis, is you test the extreme values. That's not really a proof, but it works temporarily. Write the converse. Flip the if and the then around. If all 3 angles are less than 90 degrees, then what? We have an acute, not angle, triangle, because we're talking about a specific triangle. Is that one true? Is that statement true? Say yes. You know why? This is a very, very powerful statement. We actually call these if and only if statements. If you have a statement that works both forwards and backwards, this is the definition of an acute triangle. An acute triangle is defined as one that has all angles less than 90. And an triangle with all angles less than 90 is defined as, is named, an acute triangle. Those are very, very important in logic or in programming, because usually it means you're defining something. So this is also true. It says, write down a true conditional statement for which the converse is not true. If it's raining, it's cloudy. True? If it's raining, it's cloudy outside. True? Yes. Can it rain without clouds? If it's raining, don't go, keep it obvious. If it's raining, it's cloudy. True. If it's cloudy, it's raining. Not necessarily true, because it could be cloudy and dry. Okay? There's an example of a conditional statement that's true one way, but the converse is not true. Not going to bother writing it down. Ooh. Biconditional statements. What does the prefix bi mean? To, both, conditional. These are statements that are true in both directions. These are statements for whom the conditional and when you reverse it, its converse are also true. If there are no clouds outside during the daytime, the sky is blue. True. If the sky is blue, there are no clouds outside during the daytime. Maybe not. You could say, I can't see the sky, but it's still blue. Fair enough. Well, we'll do some here. So we call these if and only if statements. In fact, often they're abbreviated if. That's the abbreviation for if and only if. In math, in logic, anytime you get an if and only if statement when you are learning new math, you put a big box around it because almost always that had a whole bunch of implications. You're like, I got to know this one. Oh, here's an example. A Canadian citizen is allowed to vote if and only if the person is at least 18 years old. Is that true? Yes. Flip it. If the person is 18 years old, then a Canadian citizen is allowed to vote. Also true. One implies the other. Usually what that also means, Kyle, is how the first thing is defined depends on the second. So for example, in this voting example, we have defined voters as you're registered and over 18 and a Canadian citizen, which means if you have one, you automatically imply the other. Example 4. A conditional statement and its converse, remember converse, reverse, if becomes then becomes if, are given. So here it is. If a triangle is obtuse angled, then the triangle has one angle between 90 degrees and 180 degrees. True or false? If a triangle is obtuse angled, then the triangle has one angle between 90 and 180. True or false? True. Can it be bigger than 180? Think about it. Why can't it be bigger than 180? Jane, what?
All three angles have to equal 180.
Okay, triangle all has to equal, Julia, 180. So it can't be bigger than 180. Can you have more than one angle bigger than 90 in a triangle? Could you have an angle of 100 degrees and another one of 100 degrees? Why not? See, we're providing a counter example, right? That would add to more than 180. So, true. Now let's look at the converse. If a triangle has one angle between 90 and 180, then the triangle is obtuse angled. You know what? That's also true because that's how we have defined an obtuse angled triangle. This is an if and only if. This is an if and only if statement. This is biconditional. Okay. It says if both statements are true, write a biconditional statement. If a triangle is obtuse angled, remove the word if. A triangle is obtuse angled. Here's where the if appears. If and only if it has one angle between, I'll move this in a second, 90 and 180 degrees. Let's see if I can move that up so you can read it. Okay? A triangle is obtuse angled if and only if it has one angle between 90 and 180 degrees. In your notes, Oscar, if you wish, you can abbreviate if and only if with IFF. But you don't have to. And since that scares some of you, I'll bring that back. So, we have Conditional statements, we have the converse, reverse the if and the then. We have biconditional, where the converse and the conditional are both true. Last one, contrapositive statements. What does positive mean? The word positive, what does it imply? What does it mean?
Good.
Okay, good or true or plus. What does contra mean?
Against.
Against. So let's see if we can use that to remember what we're talking about. Because problem here is conditional, converse, and contrapositive all begin with the letter C. So a lot of my normal methods, if you've had me before, you've heard me, for example, talk about sign, sounds like Y. A lot of my normal stupid methods don't work. So I got to come up with other stuff. The contrapositive of a conditional is formed by taking the converse of the conditional and negating both the hypothesis and the conclusion. It's the contra-positive. Contra, opposite, against. That's why you're negating it. Positive, you're taking the converse, you're reversing it. So you ready? Here is the conditional. If a Canadian citizen is 18 years of age or older, then the person is able to vote. True. Converse, reverse the if and the then. If a Canadian citizen is able to vote, then the person is 18 years of age or older. True. What's the contrapositive? Take the converse, but make everything its contra. It's opposite, the opposite of positive. It's negative. That's why it's called contrapositive. It's negative. If a Canadian citizen is not able to vote, then the person is not 18 years of age or older. Is that true? Okay. Write the converse and the contrapositive of the following conditional statement. How far are we going to? Oh, I think we're going to get through the lesson. If a triangle is obtuse angled, then the triangle has one angle between 90 and 180. Converse, reverse the if and the then. So what's the then in this first statement? Then what? That's going to be the if. Ready? If the triangle has one angle between 90 and 180, then the if becomes the then in the converse reverse. What was the if in the original statement? So then the triangle is obtuse angled. Let's see if I can move that so you can see it a little better. Okay, there's the converse. What would the contrapositive be? The opposite of both of those. If the triangle what? Does not have one angle between 90 and 180, then the triangle is not obtuse angled. This is the contrapositive. Is this contrapositive true? If a triangle doesn't have one angle between 90 and 180, then that's not called an obtuse angled triangle. Is that true? Ah! True. Sorry, I'm typing because my handwriting is atrocious, and it's larger so you can see at the back. I know I can type faster than you can handwrite, but okay. So Kyle, we have a conditional statement, if then. Converse, reverse the if then. Biconditional, if and only if. And contrapositive, the opposite, the contrapositive the negative of the converse. Turn the page. See Goldbach's conjecture? I already showed it to you. Nearly done. Considering the following if-then proposition. Now let's do some math, some numbers. If z is bigger than 2, that automatically means, that implies, then z squared is greater than 4. True? Or if not, give me a counterexample. Okay. Let's see if we can convince ourselves whether or not this is true. Give me an example. What's the smallest number bigger than 2? 3. Let's try that. Is 3 squared bigger than 4? Okay, so it worked. I always try smallest. What's the biggest? Okay, infinity. Might try it with a bigger number. The other thing I try are zeros and ones, because those behave strangely, right? 0 times 0 is, anything times 0 is 0, and 1 doesn't work well with exponents. But wait a minute, it said z has to be bigger than 2, so can I try zeros and ones? Nope. You know what? I think if you have a number bigger than 2 and you square it, the answer will always be bigger than 4. No, okay, that makes sense to me. Write the converse. Flip the if and the then. So what's the converse? If z squared is bigger than 4, then what? Z is bigger than 2. And this is why I put a line through my z's so you can tell that they're not 2's, because my writing is so atrocious. Is that true? Okay. Suppose I square a number and I get 4 as an answer. Does that automatically mean that the number I started with is bigger than 2? What's negative 3 squared? 9. Is that bigger than 4? So that satisfies the first statement. Is negative 3 bigger than 2? There's my counterexample. See it, Mackenzie? Right? Negative 3 squared gives you positive 9, but negative 3 is not bigger than 2. It does not work. This is not an if and only if statement. This does not work both ways. Oh, and again, the trick, Sterling, if you're doing number questions like this, try negatives, try zeros, try ones, try, close to, bigger, and all that stuff. Write the contrapositive. So the contrapositive is going to be the negation of the converse. What's the negation of z squared bigger than 4? If z squared is not bigger than 4, which actually means smaller than or equal to. Then z is not bigger than 2. Is that true? So if we have a number smaller than or equal, if we square something and get an answer smaller than or equal to 4, which I guess means like 3.9, or then z has to be smaller than or equal to 2. Let's see. Well, what could I square and get an answer less than 4? Or well, first of all, let's try 2, because it's less than or equal to. Put a 2 in. 2 squared is smaller than or equal to 4. Is 2 smaller than or equal to 2? 2 works. What else might I try? Try negative 2. Negative 2 squared is not bigger than 4. It's 4, which is smaller than or equal to 4. And negative 2 is definitely smaller than or equal to 2. So negative 2 works. What else might I try? I might try 1. What's 1 squared? Is 1 less than or equal to 4? Yeah. And does that also mean that 1 is less than or equal? Okay, yeah, 1 works. Might try, you know what? I think this is true. I can't find a counterexample unless someone else has thought of one. Last one. You guys have been very patient. We're done. In fact, I think this is the last lesson of the unit. Yep. Then next class is going to be review. So I'm going to give you a bunch of homework, but you'll be able to get it done on Monday too, because Monday I'm going to be pressing pause. Let's finish the lesson off. Consider the following conditional statement. All right. If Peter lives in Saskatchewan, then Peter lives in Regina. True? No. Okay. False. Write the converse. Converse, reverse the if and the then. If what? If what? Peter lives in Regina, then Peter lives in. True or not? By the way, can you see we're sort of talking about Venn diagrams. Regina as a Venn diagram would be inside the Venn diagram of Saskatchewan, but Saskatchewan as a Venn diagram is not inside the Venn diagram of Regina, which is another yet way to think of these. True or not? True. Write the contrapositive. So now negate the converse. If Peter, what? Does not live in Regina, then Peter does not live in Saskatchewan. Is that true? Because you can live in Saskatchewan, but not live in Regina. So here, false. Okay, Zach? Contrapositive, converse, conditional. And fancy schmancy biconditional works both ways. The converse and the conditional are both true. Little note then. Examples 6 and 7 are examples of the following rule. A conditional statement and its contrapositive are equivalent statements. This means that if a conditional statement is true, so is the contrapositive. If the conditional statement is false, so is the contrapositive. Woo! That's your homework. Well, get as much as you can done in class. And then you may notice, I think lesson 6 is a practice test. That's what we're going to be also working on Monday. And I'm probably going to have a practice quiz on some of this stuff on Monday, a take-home quiz. But no new homework. Try number 1. Try number 2. Try number 3. Lots of writing, I know. 4, 5. 6. Skip 7. I think I'm going to skip 8. I've skipped 7 and 8 so far. Can you wait till I finish giving up the homework?
Yeah.
Then, okay. Patience, young grasshopper. Try 9. I don't know how wild I am about that, but that's okay. Ten is tricky. It's some math, but see if you can figure it out. I'm going to pass on 11. 12 is good. 13 is good. And I think that's where we pause, okay?